Alright guys, in this video we're going to look at the basic premise of completing the square, which is to be able to rewrite things from standard form into vertex form. Or that is to say, to be able to go from things that look like this to things that look like this. And so the key kind of indicator that we have something in vertex form a lot of the time is this square of a binomial here. So we're going to start with just some basic vocabulary. It says, what must you add to the expression x squared plus bx to complete the square? One thing we want to make sure that we write over here is this. This is called a perfect square trinomial. And the big takeaway in all of completing the square is that we refer to perfect square trinomials as being any trinomial of this form, x squared plus bx, but, and I'm going to put this in a different color here, but plus half of your middle term squared, where b is this middle coefficient, right? So if you've written it this way, you are what we call a perfect square trinomial, and the result of this is the factored form x plus b halves squared. Or that is to say that the factored form of this would be x plus half of b and then x plus half of b, but we tend to just write it as x plus half of b times itself, or x plus half b squared. So up here where it says what do we need to add to this to make it a perfect square trinomial, we need to say that we need to add on half of your middle term squared. If we do that, then it's going to be a perfect square trinomial. So I'm going to put this in just because I don't have a lot of room to write. And we say that it is a perfect square trinomial in this particular instance because when you look at this, we have 1x squared minus 6x, and if you take negative 6 and we say what's half of negative 6 and square it, we get negative 3 squared, which is 9. You notice that this is a perfect square trinomial. So it's a perfect square trinomial because it equals the square of a binomial. But what would I put in here when I factor this? The neat thing is that you always just put half your middle term, or this number right here that we got when we cut our negative 6 in half. So we're going to say that this factors into x minus 3 and x minus 3. And it'd be a good thing for you to check here. If I were to factor this into x minus 3, would this work? Well, negative 3 and negative 3 multiply it to be a 9 and add up to be a negative 6. So we're going to be looking at these perfect square trinomial things. Remember I said that the idea is to be able to rewrite things into this form. Our job is going to be to solve these, and so if we can get this into vertex form, we're going to be able to use square roots to do it. So it says in the following exercises, factor the left side of the equation, then solve by using square roots. I want you to notice on the left side here, it's not going to let me write on here. We'll try again. On the left side here, it's a perfect square trinomial because I notice my a value is 1, and then half of my middle term, which would be negative 4. When I square a negative 4, I get a positive 16. So that means that I know that this left side is a perfect square trinomial, and we call it that because it is the resulting expression that we get when we square this binomial right here. So what would I put on the inside here? Remember that you put half your middle term when you factor this, but we'd get an expression that looks like this. And beyond this, I'd say I'm going to carry it off over here. If I had x minus 4 squared equals 25, at this point we could go ahead and just take a square root of both sides. And so we would get just x minus 4 on the left equals plus or minus 5 on the right. And then we could finish off by adding the 4 over to the right-hand side. We get 4 plus or minus 5, or that is to say 4 minus 5 is negative 1, and 4 plus 5 is a 9. So these would be our zeros here. So you can see that on all of these expressions here, this one here, we say that half of negative 10 is negative 5 squared is 25. This is a perfect square trinomial. So we would get an expression that factors down, and not only would it factor, but remember that this is always half your middle term. This is this value that goes in here. And again, now we can use square roots to solve this. And even taking a look down here at some of these where we say, well, half of 4 squared is not 1. Well, this is a little bit different instance, but this is still considered to be a perfect square trinomial. Notice that your outer values here are squares. So when I factor this, I would say, well, it factors into what could I square to get 4w squared? It would be 2w in front. What could I square to get 1? We'd put this in back, and because this sign is a plus, we'd put a plus here. All of this equals 75. So really quickly here, let's go ahead and take the square root of both sides. I suppose if we took the square root of the left, we're just going to get 2w plus 1. 2w plus 1. On the right side, I get plus or minus, and I'm going to write this as 25 times the square root of 3. Sorry, square root of 25 times 3, because I know that the square root of 25 is 5. I get plus or minus 5 root 3. The only things that we have kind of left to do here are to subtract the 1 over. We get negative 1 plus or minus 5 root 3. And then if we scroll down here, we would divide both sides by 2. So essentially we get w is negative 1 plus or minus 5 root 3 all over 2. Again, we can use square roots to do this because these left sides are perfect square trinomials. So factor left side, use square roots to solve it. Cheers.